Hi, in this session I will be talking about enterprise architecture methods and frameworks. This session is divided into two major parts. The first part I will be talking about enterprise architecture methods, and the second part I will be talking about enterprise architecture frameworks. Basically, in enterprise architecture methods, I will briefly mention rational unified processes. I will briefly mention UN modeling methodology, UMM, and federal enterprise architecture frameworks. In the second section, I will talk about enterprise architecture frameworks such as IEEE 2000 standard, Zachman framework, TOGAF, MDA, and some brief mention of other frameworks. Okay. In brief, an architecture method is a structured collection of techniques and processes and steps for creating and maintaining an enterprise architecture. Enterprise architecture methods typically specify the various phases of architecture's life cycle, what deliverables should be produced at each stage, and how they are verified or tested. The architecture methods are basically the tools that are developed to control the life cycle and develop the artifacts for enterprise architecture framework. One of very famous methods in enterprise architecture is URP, which is very widely adopted by IBM and as of URP rational development methodology. This methodology is based of is basically constructing and defining an iterative process as opposed to a classical waterfall process. Some of you that it's very familiar with software engineering and software development lifecycle, you know the classical waterfall process. It realizes software by adding functionality to a architecture in an incremental manner. In an iterative method, business value is delivered incrementally in time-boxed cross-discipline iteration, as you can see in this diagram. On the top, we can see the life stages of the life cycle, such as inception, elaboration, construction, and transition. At the left-hand side, we can see a process modeling, requirements, and these are the software development stages. And in every one of these stages, we develop different types of, we basically do different types of activities. So the activities are, for example, business modeling, can happen throughout the entire life cycle. So it's basically a living dynamic process. Similarly, requirements happens throughout the entire life cycle. However, you can see the test is much less, and then also the thickness and the thinness of this line you can see across the life cycle indicates that how much effort and how much activity happens for example, business modeling in every stage. As you can see, for example, when you're doing inception and elaboration, that's where you do a lot of business modeling and a lot of requirements as well. Whereas in construction and transition, you will see the modeling and requirements activities getting smaller and smaller towards the end of the life cycle. But alternatively, you can see, for example, or as opposed to that, you can see the development process doesn't really seriously start until you get to a construction phase. And then that's where you start developing artifact software components and also infrastructure components and so on. So the activity in inception and elaboration is very, very minimal, probably non-existent. And when you move to the construction and transition, you can see the major activities happening in development. However, when you can see this test happens in almost every stage. This means that it indirectly tells us that we need to test everything, not just software components. We should be testing in our elaboration. For example, we're testing our requirements, we're testing our documentation, and so on. And we'll have to test our construction phase, and then we'll have to test on transition phase. So rational unified processing is of interest to us because it defines an iterative process. And we need this iterative process opposed to the waterfall process. Okay, now next we briefly mentioned that there is another methodology. It's called UMM, that the United Nations Center for Trade Facilitation and Electronic Business has developed this. This is more of a method of modeling rather than actual methodology for development. In this, we can see on the top there UML modeling syntax that is sitting on top of UMM, and then also there is a reference guide that tells us how the syntax works, and so on. When you come down, it'll sit on top of an infrastructure and actual technologies required for these modeling. Other various consulting companies have developed their own architecture methods and frameworks. For example, DYA, IAF, IBM's enterprise architecture method, Microsoft Motion. Because of the often proprietary nature of those methods, we don't really mention every one of them. We try to talk about, or we try to pick those that are open sourced and are more widely accepted in the community. Okay, now we move on to actual enterprise architecture frameworks. As a definition, as you can see in the screen, we can define it as define a framework as a real or conceptual structure intended to serve as a support or guide for developing or building something that expands the structure into something useful. In computer systems, a framework is often a layered structure indicating what kind of programs can or should be built and how they would interrelate to each other. When we say layered structure, we basically wanted to mention a vertical layered. From the top, you can see the most abstract on the top, and also at the bottom you will have more real infrastructure hardware components. We will describe this layered architecture in very much details in future sessions, so we just basically mention it here for our reference. And we start with IEEE 2000 framework. It's a pretty sophisticated framework adopted by IEEE. It uses the civil architecture metaphor to describe software system architecture. In this sense, it is similar to the framework of Zachman. We will mention in very details the Zachman framework later in this session. IEEE Computer Society approved the IEEE 2000, which builds a solid theoretical base for the definition, analysis, and a description of some system architecture. It was adopted by ISO in year 2007. It mainly focuses on software intensive systems such as information systems, embedded systems, and composite. I must also mention that this has become a basis, or probably been feeding into some other framework that we will talk about in very details, and it will be the major part of this course, which is called TOGAF. Now I will go through this diagram with you to clarify a little more about this framework. So what the framework is saying is that, okay, if you want to create a system, your system must have a mission. Okay, what is it supposed to accomplish? And then from there you create your system. So your system is fulfilling this mission. Now the system that is fulfilling mission will be deployed in a certain environment. So it is inhabiting that environment, and it's also influenced by the environment. It definitely have an architecture, and this is what we are interested in. This system will have an architecture, and the architecture has to be described somehow. And how we describe architecture? We describe architecture by showing different views of the architecture. As we mentioned in the previous slide, we have a layered architecture. For example, the services, business systems, business services, software systems, and then at the bottom you probably have a view of infrastructure. So different views of the architecture are required. Again, we can see the architecture description will be based or provide some rationale, meaning that why we do things the way we do. And when we come down, we'll have a view. That view is created by a model, and the view is basically comes from a point of view. So for example, if we say a view as let's say a business services view, okay, so business services view is a point of view of a particular stakeholder, and that stakeholder probably is, say, your customer. So your customer stakeholder has a point of view which is services, and that services is we create a view to confirm that point of view, business services view, and that business services view is part of the architecture description. It describes the architecture from the business services view, and so on. So this is basically the very nuclear of this framework. IEEE, in more details, briefly I want to mention, provides a conceptual framework which meant to explain how the key terms relate to each other in a conceptual model for architecture description. It explains the role of the stakeholders in the creation and use of an architecture description. It provides a number of scenarios for the architectural activities during the life cycle of architectures, of single system and iterative architectures, for evolutionary systems, architecture for existing systems, and architecture of evolution. It has 6 architecture description practices. It's listed here. Architecture documentation, referring to identification, version, and overview of information. It provides an identification of system stakeholders and of their concerns, established to the relevant to the architecture. Selection of architectural viewpoints containing the specification of each viewpoint that has been selected to organize the representation of the architecture and the reasons for which it was selected. So you see, this area is where we're talking about the rationale for every architectural description, and the architectural description had be related to a particular view, and then a particular view was of a viewpoint, and every viewpoint was of a stakeholder. So as you can see, all of these are basically interrelated to each other. And then so I don't really want to read all these in the screen, so you can read it yourself. One other thing I wanted to mention is that IEEE 2000 provides recommended practices in terms of a number of very valuable concepts and terms of reference, which reflects the generally accepted trends in practice for architectural description, and codifies those elements in which there is a consensus for. There is a clear separation between the architecture and its architectural description, and that means that in central role of the relationship between architectural viewpoints and architecture view. All right, so now basically what we're trying to say is that everything comes down to when you're creating architecture, comes down to the artifacts, the things that describes the architecture, and those are your views. And then every one of those views are shared by one or more different stakeholders as their point of view. Okay. Now, moving on to more widely used framework called Zachman. The Zachman framework has been introduced as the first and the best known enterprise architecture from 1987. Applies to enterprise, is simply a logical structure for classifying and organizing the descriptive representations of an enterprise that are significant to the management of the enterprise as well as to the development of the enterprise system. It depicts the design artifacts that constitutes the intersection between the roles in the design process. So it is all about the roles of the design process. For example, the owner, the designer, the builder, these are the stakeholders. And the products, abstractions that are what, how, and where. So what are the things that supposed to be done for a particular particular role in this system in a different phase. Okay, so this is if we consider that, it will come up to a table like this. We'll say, for example, what a planner supposed to be doing in terms of a scope, okay, or enterprise modeling, okay, so and so on, right? So at the left hand side we can see the roles, the people who are working in this system, the stakeholders or the people who have interest in this architecture. On the top, we can see the questions we're asking, and in every one of these cells, we will have different views produced for that particular stakeholder. Okay, here we can see more details about that. For example, inventory identification is what we do. Okay, and how we do it is by by doing process identification, and then distribution identification, and then responsibility identification. Every one of those are described by a different model, inventory definition. So this is how we define it, because this particular modeling, artifacts that we use for this stage, and we use different modeling artifacts for every one of these stages. A Zachman frame. So basically, one of the most important advantages of Zachman framework are that it is easy to understand. It addresses the enterprise as a whole, so you can see everything that happens in an enterprise in one big sheet that has all the artifacts. Of course, this is a very simple representation. We will definitely, as the enterprise is more complex and grows bigger, that this complexity increases. It is defining independently tools or methodologies, and any issues can be mapped against it to understand where they fit. An important drawback is that the large number of cells, which is an obstacle for the practical applications of this framework. Also, the relations between the different cells are not well specified. Okay. Notwithstanding those drawbacks, again, must mention that Zachman is to be credited with providing the first comprehensive framework for enterprise architecture, and this work is still widely used and probably is can be considered as the father of most of the other more important frameworks. Okay, so from Zachman framework we come down to the open group architecture framework known as TOGAF. TOGAF has the following main components. Let me explain a little bit about it as a little short history. Zachman originated as a generic framework and methodology for developing of technical architecture, but evolved into an enterprise architecture framework and method. Currently, it's on version 9.1. And it is improving. It's dynamically improving. It's dedicated to enterprise architecture from version 8, I guess. The idea behind TOGAF is pretty simple, and it's really mentioned in this very short description in 4 points. It's an architecture capability framework which addresses the organization, process, skills, roles, and responsibilities. It has a architectural development method, ADM, known as ADM, which provides a way of working for architects. The architecture content framework also is one part of the TOGAF, composed of 4 closely interrelated architectures. So You should be describing business architecture, data architecture, applications architecture, and technology architecture, which basically at the bottom sits. It's mostly about infrastructure. And also it has something called the enterprise continuum, which comprised of various reference methods such as a technical reference model, open group standards information base, and building blocks information base. The idea behind the continuum is to illustrate how architectures are developed across enterprise continuum, ranging from foundation architecture through to common systems architecture, and move to industry-specific architecture, and finally to a particular specific organizational or individual architecture. Okay, so in this diagram we can see a very brief description of, not description, basically illustration of TOGAF. Okay, now we will use TOGAF as our selected enterprise architecture framework throughout this unit. In next session we will specifically talk about what TOGAF is and how it works and all these small little components of TOGAF and all the interrelations of those small components. Okay, as I mentioned, TOGAF has a tool or modeling tool. It's called Architecture Development Model. It's is a generic method and is intended to be used by enterprise in a wide variety of different geographical and applied in different vertical sector industry types. As such, it may be, but does not necessarily have to be tailored to specific needs. For example, it may be used in conjunction with sets of deliverables of another framework, such as Zachman, where these have been deemed to be more appropriate for a specific organization. So if you're developing for a specific organization, you have a capability, or TOGAF gives you the capability of modifying it or even combining it with other frameworks. It may be used in conjunction with other well-known, as I mentioned, frameworks such as Zachman. ADM works in iteration. It has capability of moving between phases, and within those phases, for each iteration of the ADM, a fresh decision must be taken as to the breadth of the coverage of the enterprise to be defined, the level of details of the enterprise coverage should be defined as well, the extent of the time horizon aimed at, including the number of extent of any intermediate time horizons, the architecture assets to be leveraged in the organization's enterprise continuum, including assets created in previous iterations of ADM cycle within the enterprise, and assets available elsewhere in the industry. So you use not only the enterprise, the building blocks available already in the industry, or in particular industry, you can also use your own building blocks or build your own building blocks. This is what ADM looks like. We will talk about this method and within the TOGAF description in 2 whole session. Other architecture frameworks, the name is very close to the ADM, but it's not ADM. This is OMG's Model Driven Architecture, MDA. It's very ironically very close to ADM. MDA built upon the Object Management Group Modeling Standard, the Unified Modeling Language, UML. So it is building on top of the UML. It is also building on top of meta object facilities of the OMG again in 2006, and the Common Warehouse Meta Model of CWM. It is a platform-independent application. Descriptions built with those standards can be realized using different open or proprietary platforms such as Corba, Java, .NET, and so on, even web services. MDM aims to provide a vendor-neutral approach to interoperability. The OMG has extended the focus of MDA to the computation-independent model called CIM, in which the business aspects of the company are covered. Thus, MDA comprised of 3 abstract levels. The requirements for the system are modeled in a computational independent model, describing the situation in which the system will be used. Such a model is sometimes called a domain model or a business model. It hides much or all of the information about the use of automated data processing system. Second, the platform independent model, PIM, describes the operations of a system while hiding the detail necessary for a particular platform. A MIP shows that parts of the complete specification that does not change from one platform to another. So it's showing the generic specification of the system. One of the key features of MDA is the notion of mapping. A mapping is a set of rules and techniques used to modify one model to get another model. So that's how it's depicted. Okay, there are other frameworks that we just mentioned here. Not much of an interest to our session, just for our information to be aware of. Things like DODAF, which belongs to the Department of Defense of the United States. These models and frameworks are very specific, although every enterprise architecture framework had or has had their influence on each other or on the other enterprise architecture frameworks such as TOGAF and Zachman and so on.